moderating effect on the relationship between the independent variable and dependent variable. Okay, so moderation with regression analysis. In statistics and regression analysis, moderation occurs when the relationship between the two variables depends on the third variable. The third variable is referred to as the moderator variable or simply the moderator. The effect of the moderating variable is characterized statistically as the interaction, that is, a categorical or a quantitative variable that affects the direction and or the strength of the relation between dependent and independent variable. So specifically, within the correlational analysis framework, a moderator is a third variable that affects the zero order correlation between two other variables or the value of the slope in the dependent variable on the independent variable. The in analysis of variance, the basic moderator effect can be represented as an interaction between a focal independent variable and a factor that specifies the approximate condition of its operation. A moderating variable is also called a moderator variable or simply M, changes the strength or the direction an of an effect between two variables, the independent and dependent variable. In other words, it affects the relationship between the uh, predictor and the criterion variable. Moderating variable can be quantitative, which is non-numerical values, and quantitative, which are of course numerical values. Okay, so these are the um, some the ways in the moderated regression analysis. Okay, so you have the first one is a simple regression, y equals alpha plus beta sub 1 x, or in this case the alpha is the uh, y-intercept and beta sub 1 is the coefficient of our x. Then we could also have y equals uh, the intercept plus the x sub 1, the beta 1 x sub, the beta x sub 1 x plus beta 2 z. And the third one is you have there y equals the intercept plus beta sub 1 x plus beta sub 2 z plus beta sub 3 x z. So in this equation, that especially the third equation, okay, uh, if the interaction between the independent variable and the moderator, okay, which is the xz, the xz, this one, is not statistically significant, then z is not a moderator variable. It is just an independent variable. So take note that if the coefficient of our xz is not significant, then z is not a moderator. If it is statistically significant, then z will be a moderator variable, and thus moderation is supported. In the regression equation, when the relationship between the dependent variable and the independent variable is linear, then the dependent variable may change when the value of the moderator variable changes. In a linear relationship, the equation, this one, this equation, okay, is the representation of the effect. Okay, in this equation, the relationship is linear and represents the interaction effect of the moderator and the independent variable. Okay, so these are the assumptions. You have the causal assumption. When x variable is not randomized, then causation must be assumed. The moderator variable can reverse the effect, the causation, if the causation between x and y is not presumed. Okay, so okay, uh, causal variable relationship. The moderator variable and the independent variable, in principle, should not be related. So no special interpretation can be found between a correlated independent and moderator variable. However, they should not be too highly correlated. Otherwise, estimation problems may occur. The moderator variable must be related to the dependent variable. And you have also the measurement. Usually the moderator or moderation effect is represented by the interaction effect between the dependent and independent variable. Okay, so let's have another assumptions. We have here your independent variable should be measured on a continuous scale. So it's either an interval or ratio. So the dependent variable should be measured in a continuous scale. For example, the variables that meets this criterion should revision time, let's say measured in hours or intelligence or the exam performance or the weight and so forth. Okay, you have one independent variable with a continuous uh, and one moderator variable that is dichotomous. Okay, or the nominal variable with two groups. So in this case, okay, the examples, okay, you have clearly stated there that it could be interval or ratio, and it could be uh, nominal with two groups. Okay, you should have independence of observation, so independence of residual. So in this case, some of the uh, you can check, actually we can the statistician can check the independence of residuals by using Dorbin Watson statistic, which is a simple test using SPSS. Okay, then you have also there uh, there's need to be a linear relationship between the dependent variable and independent variable for each group of the dichotomous moderator variable. Whilst there are a number of ways to check of this linear relationship, of course we can still use the scatter plot and then visually inspecting this scatter plot to check for linearity. If the relationship displayed in your scatter plot is not linear, you will have to either run a nonlinear regression analysis or transform the data, which you can use. You can do that using SPSS statistics. Okay. In the enhanced moderator guide, we show how to create and interpret scatter plot to check the linearity when carrying out the moderator analysis using SPSS. But in this case, we could not use SPSS. Okay, next. Okay, your data needs to show homodiscasticity. Okay, which is when the error variances are the same on all combinations of independent and moderator variable. So um, we explain more about what this means and how to assess the homodiscosity in the data. Okay, in the analysis, especially when we do that in SPSS. However, we could not do that in here because we are not going to use SPSS. Okay, your data must not show multicollinearity, which occurs when you have two or more independent variable that are highly correlated with each other. Okay, and then there should be no significant outliers, high leverage points, or highly influential points. Outliers, leverage, and influential points are different terms used to represent observations in your data set that are in some ways unusual when you wish to perform a moderator analysis. And finally, you check the uh, you need to check that the residual errors are approximately normally distributed. Okay. So let's have this one. The coach wants to determine if the age moderates the relationship between the training and the muscle percentage. Okay. So in this case, we can draw, okay, the the conceptual framework of this moderation. So this would be the uh, conceptual paradigm. Okay, the training, okay, affects the muscle percentage or the composition of muscle. However, the age here moderates the relationship between the training and the muscles. So let's try to check. So here's the data. We have the muscle composition, the age, the training. Now take note that in the discussion that we had, there is a interaction between the age and the training. So in this case, what we are just going to do here is that we are multiplying the age and the training. So this is the result. So we have the age and the training. Now what we are going to do here in the moderation is that we are just going to run multiple regression analysis. Okay, with the components of the age, the training in the age, and the interaction of the age and training. And our dependent variable would be the muscle composition. So what we're going to do here is just we go to add-ins, megastat, and then we go to uh, where's the correlation, regression, and then regression analysis. So in this case, we are just going to have our independent variable, which would be the age, the training, and the interaction of the age and the training. And then for the dependent variable, we have the muscle composition. Technically, we should do first the satisfaction of the assumption, but uh, in this presentation, we just go directly to the regression analysis. But in real case, in the real scenario, we have first to satisfy the assumptions before moving to the regression analysis. So let's say that all of the data, our data satisfies the assumptions of the moderation analysis. Then let's move to regression. Then click OK. So here, oops, so here in the regression analysis, we can visually see here that the interaction of age and training is a significant predictor to our muscle composition because the p-value of the interaction is less than 0.05. So since the p-value of the age of the interaction is significant, then we could say that the age is a moderation or a moderator to our relationship between the training in hours to the muscle composition, the muscle percentage. So here in this analysis, since we can see here that the age is a moderator, then in this case, we could have uh, 0.09, okay, or how we call this one? You have you have uh, the age is positively related to the muscle percentage. Okay, on average, the let's say the respondents or the participants, okay, uh, since it's positive, the participants gain, okay, the uh, you have 0.09%, okay, percentage points per year in this case. So 0.0009%, okay, points per year. And then in the training, okay, the training hours are positively related to the muscle percentage. Okay, so the clients gain, you have 0 0.0207% points. Okay, for each hour they work, uh, the workout per week. Okay, and here our beta is the intercept. Ah, okay, not the intercept, the beta coefficient, the B coefficient of the interaction is negative. Okay, so the negative coefficient of the interaction predictor indicates that the training effects becomes more negative or more or less positive with the increase of ages. Okay, so that's how we are going to interpret the interaction. So uh, in in more detailed approach, okay, for any effect to bear importance, uh, it must be statistically significant, and it should have a reasonable effect size. So the megastat could not have the effect size. Okay, SPSS can do the effect size. Okay, to have a more detailed explanation of the moderation, because there must be an explanation of the effect size, because uh, the you could have the semi-partial correlation. Okay, which if zero point 0.1, it indicates small effect. If it is zero point 0.3, that indicates medium effect. And if it is zero point 0.5, it indicates large effect. But in this case, we could not have the semi-partial correlation, which indicates the effect size. Okay. But if we are just going to have only this presentation, we could say that the age is a moderator to the interaction between the training and the age. Okay.